One ocean, one shift in temperature, and billions of people can feel the consequences. El Nino is one of the most powerful climate patterns on Earth. It can change rainfall, disrupt fisheries, trigger droughts, intensify heat, influence storms, and reshape weather patterns across entire continents. In some places, it brings catastrophic floods. In others, it brings months of drought. For coral reefs, seabirds, farmers, fishing communities, and coastal cities, El Nino can be the difference between survival and collapse. And now, scientists are watching the Pacific Ocean closely because some forecasts suggest this El Nino could become exceptionally strong. But how can a patch of warmer water in the tropical Pacific affect the whole planet? Why does it happen? And why could El Nino become even more dangerous in a warming world? To understand that, we have to start in the largest ocean on Earth, the Pacific. Under normal conditions, strong winds called trade winds blow across the tropical Pacific from east to west. These winds push warm surface water toward Indonesia and Australia. That warm water piles up in the western Pacific, while on the other side of the ocean, near Peru and Ecuador, colder water rises from deep below the surface. This rising cold water is called upwelling, and it is extremely important. Cold water from the deep ocean carries nutrients. Those nutrients feed plankton. Plankton feed fish. Fish feed seabirds, sea lions, whales, and millions of people. So, under normal conditions, the eastern Pacific near Peru is one of the richest fishing regions on Earth. But during El Nino, the system changes. The trade winds weaken. Sometimes they even reverse. Warm water that was pushed toward the western Pacific begins to move back east across the ocean. The cold upwelling near South America weakens, and the central and eastern tropical Pacific becomes much warmer than usual. That warming may sound small, sometimes just 1, 2, or a few degrees Celsius above normal. But across a massive area of ocean, it represents an enormous amount of extra heat. And that heat does not stay in the water. It changes the atmosphere above it. It shifts where huge tropical thunderstorms form. It changes jet streams, and those changes ripple outward across the planet. El Nino is only one part of a larger cycle called ENSO, the El Nino Southern Oscillation. ENSO has 3 main phases. El Nino is the warm phase, when the central and eastern tropical Pacific become warmer than normal. La Niña is the cool phase, when those waters become cooler than normal and the trade winds are usually stronger. And neutral conditions are when the system is somewhere in between. This cycle happens naturally every few years, but even though El Nino is natural, its impacts can be anything but small. Not every El Nino is the same. Some are weak, some are moderate, and a few become extremely powerful. The strongest El Nino events in modern history include 1982-83, 1997-98, and 2015-16. There was also an extremely intense event in 1877-78, which coincided with devastating droughts and famines in parts of the world. During strong El Nino events, sea surface temperatures in key parts of the Pacific can rise far above normal. In some regions, anomalies can approach or exceed several degrees Celsius, depending on the exact location and measurement used. To see the first consequences of El Nino, look beneath the surface. Coral reefs are among the most vulnerable ecosystems on Earth. They may look like rocks, but corals are living animals. They depend on tiny algae living inside their tissues. These algae provide much of the coral's food and give reefs their color. But when the water becomes too warm for too long, corals become stressed and expel those algae. The coral turns white. This is called coral bleaching. Bleached coral is not always dead, but it is starving and weakened. If the heat continues, entire reefs can die. Interesting fact on screen: more than 25% of all marine species depend on coral reefs at some point in their lives. That means coral bleaching is not just a problem for coral. It affects fish, turtles, sharks, coastal communities, tourism, and food security. During powerful El Nino events, coral bleaching can become global.
The 2015-16 El Nino contributed to one of the worst coral bleaching events ever recorded, affecting reefs across the tropics. But coral is only part of the story. Near Peru, El Nino can disrupt one of the most productive marine ecosystems on the planet. Normally, cold, nutrient-rich water rises along the coast. But during El Nino, warm water suppresses the upwelling. Fewer nutrients reach the surface. Plankton decline. Anchovies move, reproduce less successfully, or die off, and the entire food chain feels it. Seabirds struggle to find food. Sea lions and seals may lose pups. Larger predators, including whales, can be affected too. One change in ocean temperature, then plankton, then fish, then birds, then mammals, then people. Everything is connected. El Nino does not create the same weather everywhere. Its effects depend on the region, the season, and the strength of the event. But there are patterns scientists recognize. Along the west coast of South America, especially in Peru and Ecuador, El Nino can bring extreme rainfall. Places that are normally dry can suddenly face floods, landslides, damaged roads, destroyed homes, and outbreaks of disease after standing water spreads. In Indonesia, El Nino often brings drier conditions. That can lead to drought, crop stress, and forest fires. In some years, smoke from fires in Indonesia has created severe air pollution across Southeast Asia. In Australia, El Nino is often linked to hotter and drier conditions, increasing the risk of drought, heat waves, and bushfires. In India, El Nino can influence the monsoon. It does not automatically mean the monsoon will fail, but it can increase the risk of weaker rainfall in some years, which matters enormously for agriculture and water supplies. In Africa, the impacts vary by region. Some areas may face drought, others may see unusually heavy rainfall and flooding. In parts of southern Africa, El Nino has often been associated with drought risk, while parts of eastern Africa can sometimes become wetter. And in North America, El Nino can shift the jet stream. That often means wetter conditions across parts of the southern United States during winter, while parts of the northern US and Canada may be warmer than average. Interesting fact on screen: ENSO can indirectly influence weather patterns affecting around 70–80% of the world's population. That does not mean El Nino controls everyone's weather. Local weather still matters. Other climate patterns still matter. But ENSO is one of the biggest sources of year-to-year climate variation on Earth. One common misunderstanding is that El Nino simply means more storms. It is more complicated than that. El Nino changes where storms are more likely to form, how strong they can become, and which regions are most exposed. In the Pacific, El Nino can shift tropical cyclone activity eastward. Some islands that are normally less exposed may face higher risk. In the central and eastern Pacific, hurricane activity can increase during El Nino years. But in the Atlantic, El Nino often has the opposite effect. Why? Because El Nino tends to increase vertical wind shear over the tropical Atlantic. Wind shear means winds are blowing at different speeds or directions at different heights in the atmosphere. Hurricanes need a relatively organized vertical structure to grow. Strong wind shear can tear developing storms apart. So during El Nino years, the Atlantic hurricane season is often less active than it would otherwise be. But that does not mean there is no danger. Even in a quieter Atlantic season, One storm hitting the wrong place can still be catastrophic. The key is not just how many storms form, it is where they go, how strong they become, and how vulnerable the coastline is when they arrive. In the Pacific, island communities can experience El Nino in very direct ways. Take Hawaii. El Nino can influence ocean temperatures, rainfall patterns, storm tracks, and wave activity. Warmer water can increase stress on coral reefs. Changes in currents and marine ecosystems can affect fish populations. Higher or unusual wave patterns can increase coastal erosion. Beaches can shrink. Roads, homes, hotels, and cultural sites near the shoreline can become more vulnerable. And for low-lying islands across the Pacific, the risks can be even greater. Some islands depend heavily on rainfall for fresh water. If El Nino shifts rainfall away, drought can become a serious threat. Other islands may face stronger storms, coastal flooding, or damage to reefs that normally help protect the shore from waves. Coral reefs act like natural breakwaters. When reefs are healthy, they absorb wave energy. When reefs are damaged by heat, bleaching, pollution, or storms, coastlines become more exposed. Interesting fact on screen, satellites now track sea level and ocean temperature almost in real time, helping scientists monitor ENSO far better than in the past. This is one reason El Nino forecasting has improved so much. Today, satellites, ocean buoys, computer models, and deep ocean measurements allow scientists to watch the Pacific in ways that were impossible a century ago. The ocean is still complex. Forecasts are never perfect, but we are no longer blind. El Nino is not just a weather story. It is a human story. When rains fail, crops fail. When crops fail, food prices rise. When reservoirs dry up, cities and farms compete for water. When floods hit, homes are destroyed, roads collapse, and diseases can spread through contaminated water. When heat waves intensify, the elderly, outdoor workers, and people without cooling are at greatest risk, and history shows how severe the consequences can be. The 1877-78 El Nino was one of the strongest events ever identified. It coincided with devastating droughts and famines in parts of India, China, Brazil, and Africa. Historians estimate that millions of people died during famines linked to those climate extremes. Although exact numbers vary widely, and the disaster was shaped not only by weather, but also by politics, poverty, colonial policies, and weak disaster response. The 1982-83 El Nino caused major flooding, droughts, fires, and economic damage around the world. The 1997-98 El Nino was one of the most powerful on record. It caused thousands of deaths and tens of billions of dollars in damage globally. The 2015-16 El Nino helped push global temperatures to record levels, intensified drought in several regions, contributed to severe fires, worsened food insecurity, and played a major role in global coral bleaching. Large El Nino events can cause global economic damage reaching tens to hundreds of billions of dollars. But the damage is never distributed equally. Wealthier countries may recover faster. Poorer communities often suffer longer. Farmers, fishing families, island nations, and people living in flood-prone or drought-prone regions are often hit hardest. El Nino exposes a simple truth. Climate risk is not only about nature, it is also about vulnerability. Sea levels are higher. Coral reefs are weaker. Forests are under more stress. More people live in vulnerable places, and the atmosphere contains more energy and more moisture than it did in the past. So when a strong El Nino arrives, it does not arrive alone. It arrives on top of a changing climate. That is what makes it so important to understand. A small shift in sea surface temperature across the tropical Pacific can move rain belts, weaken fisheries, bleach coral reefs, change storm patterns, raise food prices, and affect billions of lives. The Pacific may seem far away, but the ocean is not separate from us. It feeds us. It shapes our weather. It stores heat. It moves energy around the planet. And when it changes, the world changes with it. One temperature change in the Pacific Ocean can influence the lives of billions of people. In the end, the ocean connects the entire world.